In the end of the last lesson, we looked at a type of factoring that involved greatest common factor. And we're going to look at a type of factoring today that you do when your polynomial does not have a greatest common factor, right? Like not everything has a GCF. So what do? One of the most common types of polynomials that you'll need to factor is a trinomial. So we're going to look very specifically at a trinomial in this specific form, x squared plus bx plus c. When you write a polynomial as a product of its factors, it's called factoring. Here's how you do it. The first thing that you do is you make a list of the factors of the c term. So factors are two numbers that multiply to get the number, and the c term would be this constant term, the one that does not have the variable. So our trinomials will always be in this form in this lesson, and we start off with finding factors, meaning numbers that multiply, to this value right here. Then we use those pairs and we think, how can I add to get the b term? And the b term is this term in the middle. So what we're looking for is two numbers that multiply to the c and add to the b. And if you don't understand that, just play along. Then in number 3, we have this method, which is something that I call it. It's not the official algebra name for it, but it's got a catchy phrase. We're going to use this thing called the double bubble method to write two binomials. And this piece down here is really just a fun fact. You don't have to memorize it. When the c value is positive, the two numbers will have the same sign as b. When the c value is negative, the two numbers will have different signs. One will be positive, one will be negative. That's not necessarily anything you have to memorize, but it might be helpful if you need it. So let's look at what these steps tell us to do. In example 1, they want us to factor x squared plus 10x plus 16. So the first thing that we do is we make a list of the factors of the c term. So what two numbers multiply to 16? Now, after you get to be more advanced with this, you don't have to write out the list, but I'm going to go to the side. I'm going to write out the list. So I've got 1 and 16. I've got 2 and 8, 4 and 4. Right? I also have -1, -16, right? Don't forget the negatives. -2, -8, and -4, -4. So those are all the pairs of integers that multiply to 16. Number 2 tells me to think about using those pairs, how can we add to get to b term? One of these pairs, when you add them, will give you 10, right here in the middle. So which pair, when you add, gives you positive 10? Right, it's this one right here, 2 and 8. So we're almost there. Now what we're going to do is we're going to set up this thing that I call the double bubble, which is just a miscellaneous way of saying we're going to set up two binomials. Our variable is x, because that's the variable in the question. And now we're going to take these two numbers, 2 and 8, and plug them in. Now we pick the positive versions, so it's going to be x plus 2 times x plus 8. And that's our answer. If you want to check yourself, you can go through and either FOIL or box this this multiplication question and see if you get the original trinomial that we had as your final answer. But this is the answer. This is the factored form of the trinomial. All right, if you want to do example 2 on your own, you're more than welcome to, if you kind of get the steps. If not, then just play along with me. So I'm looking for factor pairs of positive 12. So let's come up with 1 and 12, 2 and 6, 3 and 4, and then I've got -1 and -12, -2, -6, -3, -4. Like I said, as you get more familiar with this, you don't have to write the list, you can just think it in your head. So now what we're doing is we're looking for two numbers from this list that when you add them, you get -8. Which pair adds to -8? Good, it's this one. So I'm going to do my double bubble. I'm almost there. The variable in the question is x, so that's what I'll use. And then I'll just put my pair right inside, -2, -8. And if you want to multiply those binomials, you can check to see if you get that trinomial when you go through the work. All right, they're all pretty much the same. What I'm going to do is I'm just going to get you started on example 3, and then I would love for you to finish it on your own. What we're looking for is we're looking for factor pairs of negative 21. So here's the plan. You're going to make a list of numbers that multiply to negative 21. You're going to look at your list and see which pair adds to positive 4, and then you're going to put them in your binomials. When you have all that, press play. All right, last thing before we move on is kids will say to me, does it matter whether you put the negative 3 first or the 7 first? And it doesn't. So, as you know, order of multiplication is commutative from 3rd grade. So it really doesn't matter as long as the 3 is the negative and the 7 is the positive. It doesn't matter which is first. All right, now that's the overall understanding of this lesson. Now we're going to ramp it up to a word problem. There's a lot involved, so let's take it step by step. A farmer plants a rectangular pumpkin patch in the northeast corner of the square plot of land. The area of the pumpkin patch is 600 square meters. What is the area of the square plot of land? So they want us to find the overall area. They tell us that this piece right here is 600, but we don't even know the length and width of that pumpkin patch, so, what do you do now? Well, what we can do is we can look at what they give us. So they told us that this whole length is S, and they told us that this length is 40. Now, since they say that it's a square, I know that all 4 sides are the same. So if this is S and this is 40, then this must be the remaining piece, which we're going to call S minus 40. Using that idea, what would the length of this side be? It's S minus 30 because this side is S and they give us that it's 30. So it's a little longer on this side than it is over here. All right, so now what we do know is we know the 600 is the final area, and we know the length and the width of the pumpkin patch. So what we can do is we can say S minus 40 times S minus 30 equals 600. I'm just doing length times width of the pumpkin patch. So how does that help me, right? So I can multiply these two binomials. Hey, why not? I can, so I'm not really sure where to go. So let's just do it. So this would give me S squared minus 30S minus 40S plus 1200 equals 600. Now I'm going to combine all my like terms. S squared minus 70S plus 1200 equals 600. And I'm going to use my idea from a previous lesson that if I set it equal to 0, that's probably helpful somehow. Even if I don't know why yet, setting polynomials equal to 0 is helpful. Write that down. So let's do it. S squared minus 70S, that would end up being plus 600, right, when I move the 600 over, equals 0. All right, now another thing that we learned in an earlier lesson is that if a polynomial is in factored form and it equals 0, we can find the values of S. So something also helpful to know is that if you're not sure what to do, factor the polynomial. So I can factor this. I need pairs that multiply to 600, and they have to add to negative 70. So obviously it's not going to be 601, right? So come up with a list, and hopefully you're a good guesser. What two numbers multiply to 600 and add to negative 70? Hopefully you guessed quickly. It's negative 10 and negative 60. So I can go to the double bubble. It's S minus 10, S minus 60 equals 0. So hopefully you should feel like you're getting somewhere, because what we can do is we can drop a line down our factors and say, well, either S minus 10 equals 0 or S minus 60 equals 0. We can't do this if it doesn't equal 0, but luckily we made it equal 0 in an earlier step. So the two options for S are 10 and 60. So now I'm going to go up to the picture. My choices for S are 10 or 60. And I want you to think for a second, because one of these choices doesn't make sense. Do you think S is 10 or 60? If you picked 60, you're correct, because how can it be 10 if this part right here is 40? And how could it be 10 if this part here is 30? Obviously, S has to be bigger than both 30 and 40, so S has to be 60, so we're almost there. We know what S is, right? So S equals 60. We're gonna call this a rejected answer because it doesn't make sense in the story. And now I'm going to take my 60. I'm going to be so excited because I'm almost done. Let's go back up to the picture. And the final question says, what is the area of the square plot of land? So now that I know that S is 60, the answer is going to be 60 times 60 because that's how you find area of a square or of just any rectangle. So the area is 60 times 60 or 60 squared. So the area is 3,600 square meters. Whew! And we're done. All right, if you have any questions, write them down and ask me when you come to class.